functions VC equal to V0 e to the I omega t, and IC. C stands for complex, right? IC and VC. Because obviously the voltage, can it be complex in real life?
No.
No, after all, you're measuring things using meter sticks and galvanometers and clocks and things like this. It just can't be an imaginary thing. Okay, so it says we have added the subscript C to distinguish it from the real functions. So here it is. So for problem 10, we're given the following. V is V0 e to the I omega t, this complexified VC, I think, VC, yeah. And then IC is I0 e to the I omega t minus phi. We're using the letter phi. So it says find the real and complex parts of these. Part 1. Real part of VC is what?
V naught cosine omega t.
Thank you. Real part of IC.
I naught cosine omega t minus phi.
Yep. Thank you. And then, of course, the imaginary parts would be the sign, right? Part 2 says find the imaginary parts. Imaginary of VC is V naught times the sine of omega t. Imaginary of IC would be I naught sine omega t minus. Okay. All right, so that was those were parts 1 and 2. It says here for part 3, it says in the previous problem you showed that if A is a real number and Z is a complex number equal, Z equal to Z0 e to the I theta, then A times the real part of Z is the same as the real part of A times Z. And similarly for the imaginary. It says you also shows, it should say you also showed, right? It's a typo. All right. In the previous problem, you also showed in the previous problem that if the phase is a function of t, you take the derivative of the real part is the same as taking the real part of the derivative, right? The derivative of the real part is the same as doing what? Real part of the derivative. And the same thing for the imaginary, right? Derivative of the imaginary part is the same as the imaginary part of the derivative. And you can imagine doing the derivative twice, right? Derivative of the imaginary part is the same as the imaginary of the derivative of the derivative. Okay. So for case 1, it says if R is a real number and V is equal to IR, find expression for VC in terms of IC and R. So what can we say? I don't want to go through. Let's go. Yeah, why not? Part 3. Suppose R is real. If R is real, it's a real number. And R, by the way, stands for resistance. It could be a real number. R is a real number, and V is equal to IR. Right? This is Ohm's law. V is equal to IR. It says find an expression for the complexified for VC and IC. So we know. What do we know? We know that V is the real part of VC, right? And I is the real part of IC, right? Okay. Then what? So I have this. I have written the following. The real part of VC, right, is equal to V. Yeah? Which is equal to IR. Right? V, which is equal to IR. Which is equal to R, but I is the real part of what? Of IC. Yeah? But a real number times the real part of a complex number is the same as the real part of the real number times the complex number. Right? So this is the same as the real part of the R times IC, right? Therefore what? VC equals to IR. Still. So that means, so the real part of this equal to this. So VC equal to R IC. Kind of cheated. This is not complete. Why not?
Well, IC is I naught.
But I'm assuming something. I'm saying, what does this assume? If the real parts are equal, then the complex numbers are equal. Is that true?
Yeah.
You have to have the real parts and imaginary parts both equal. But you can do the same exercise with the imaginary part, right? Just change this to imaginary. So this is true. That's all. So this is true.
So we'll just leave it.
And okay. So this is for resistors. The next one is it says case B. Suppose L is the real numbers and di dt is equal to 1 over LV. Or are they trying to plug in here? What do you think L would stand for? It's a real number, but huh? L, the inductance, right? Yeah. So
Inductor.
yeah, an inductor has an inductance, right? So for part is this?
Oh, 3 case.
Yeah, so case B, right? Case B. So I have this. L is real. And di dt is equal to 1 over L times V, right? And so basically we would like to show that di C dt equals to 1 over L VC. That's what we want to do. Yeah, for sure. I guess I will just probably stop here, and then maybe tomorrow we'll continue this one.